There are no more excuses for this. James Webb Telescope finds first real evidence that shakes our cosmology. Nobody can still hold on to old theories and claim that they are still true. A new truth has dawned for scientists with the start of the James Webb mission. They must now admit that they have been wrong for decades and have sold us pure assumptions as incontrovertible truths. What else can we say? The James Webb Telescope provides a wealth of evidence that the theory of the Big Bang and the entire standard model of cosmology are wrong. But it almost seems as if astronomers, astrophysicists, and cosmologists have been living without reality. They still claim that there was a Big Bang 13.8 billion years ago from which our universe was created. But how can the James Webb Telescope show us images of galaxies that must have been several billion years old when James Webb photographed them? Sears 2112 is an almost exact twin of our Milky Way, which is 13.6 billion years old. Sears 201112 existed as a beautiful barred spiral galaxy only 2 billion years after the Big Bang. The galaxy Aztec 71 existed only 900 million years after the Big Bang and could not be seen by any telescope other than James Webb. JWST 13 existed as a complete and luminous galaxy only 320 million years after the formation of the universe. This makes it currently the oldest confirmed galaxy since observations began. These galaxies are so far developed that according to previous cosmological assumptions, they should be several billion years old, billions, mind you. But these galaxies only existed a few hundred million years after the supposed Big Bang. These galaxies are so complex that they can never be baby galaxies far and wide. There are no galaxies in sight that look as if they have just come into existence. All researchers see are large, luminous galaxies containing a lot of stars. Science continues to lie. The mystery of these too big and too early galaxies presents astronomers with a huge challenge. They ask the question, how could these massive galaxies form in a fraction of the time that would normally be required for such an evolution? But no one in the scientific community seems to be even close to questioning the Big Bang. Instead, scientists continue to firmly believe that this starting point occurred 13.8 billion years ago. They claim that stars and galaxies then grew faster. But hardly any scientists want to talk about the fact that the universe is possibly much older than previously assumed. If we look back at the history of science, however, we have to admit that many theories were based purely on observations and assumptions. Even the theory of expansion, which ultimately also proved the Big Bang, has since been called into question by other observations. Let's take a look at some of the crazy ideas that scientists have now come up with to save their beloved Big Bang. What is bursty star formation? No one can deny anymore that the discoveries of the James Webb Space Telescope are turning our previous theories about early proto-galaxies on their head. With its groundbreaking technology, the JWST has detected thousands of unusual bright galaxies whose radiance and size push the boundaries of astrophysics. These galaxies, which are similar in luminosity to our own Milky Way, were formed at a time when the universe was supposedly just beginning to form its first proto-galaxies or clusters of stars. Some scientists argue that the answer could lie in a phenomenon known as bursty star formation. In contrast to the steady rate of star formation in today's universe, these early stars may have formed in sudden intense bursts, followed by longer periods of quiescence. This theory is supported by supercomputer simulations that recreated the dynamics of gas in the early universe and supposedly prove that there were extreme rates of star formation in the early cosmos, and somehow these also formed hundreds or probably thousands or millions of galaxies at breakneck speed. The JWST discoveries challenge the standard model of cosmology, which assumes a slow, hierarchical growth of galaxies. The new simulation results now show that a galactic system does not necessarily have to be massive to shine brightly. If star formation occurred in massive bursts, these galaxies would have to emit short but intense flashes of light. This should explain why we can observe several very bright galaxies that were formed at a time when the universe was less than 400 million years old. Galaxy formation. There's a fascinating uncertainty in astronomy about the exact time of the formation of the first galaxies. However, this question would be of central importance for our understanding of the universe and its development. Traditionally, cosmologists have assumed that the first star clusters, the precursors of today's galaxies, formed gradually within the first few 100 million years after the Big Bang. The Big Bang itself is dated to around 13.8 billion years before our time. In this early phase of the universe, between the Big Bang and the formation of the first stars, is known as the Dark Ages. The first star clusters that formed in this era were to be the building blocks for the later galaxies. Cosmologists have estimated that these processes were slow and steady, with the first proto-galaxies believed to have formed around 200 to 400 million years after the Big Bang. These estimates were previously based on models of stellar evolution calculated using the known rules for the dynamics of gas and dust in the early universe. However, the latest observations by the JWST show something different. Not a single galaxy discovered by James Webb even comes close to matching these models of stellar evolution. With its unrivaled ability to peer into the depths of the universe, the JWST has captured images of galaxies so close to the Big Bang that all previous models fail. Although these galaxies existed 300 to 900 million years after the Big Bang, if we include the time it took them to evolve, the galaxies would have to have formed before the Big Bang. This would mean that the theory of the Big Bang is wrong, or at least not entirely correct. But how did researchers actually come up with the idea that the Big Bang took place 13.8 billion years ago? The estimate that the universe is around 13.8 billion years old is based on several scientific observations. In 1929, astronomer Edwin Hubble discovered that distant galaxies were moving away from the Earth, and the further away they were, the faster they moved. This phenomenon became known as Hubble's law, and it suggests that the universe is expanding. By reversing this expansion, it's theoretically possible to go back to a point when the universe was very small, which corresponds to the presumed time of the Big Bang. Press the subscribe button now to see even more exciting topics on space and astronomy in the future. The discovery of the cosmic microwave background radiation, CMB, in 1965 by Arno Penzias and Robert Wilson is interpreted as further evidence. The CMB is a faint glow that permeates the entire universe. Astronomers assume that it's a consequence of reionization, which made the universe transparent to light, and thus the CMB would be something like the afterglow of the Big Bang. The directions of movement of the CMB have so far seemed to support ideas of an expansion of space as after an initial event. Calculations of the age of the universe are also based on back calculations of the CMB. The Standard Model of Cosmology, which is based on Einstein's general theory of relativity, describes a universe dominated by dark matter and dark energy. Dark energy counteracts gravity and accelerates the expansion of the universe, which was also taken into account when calculating the age. Last but not least, the measurement of the distances and speeds of very old galaxies and stars also contributed to the calculations. However, we have now reached the threshold where the previous models are no longer tenable. The fact is that the CMB can also be interpreted quite differently. The expansion of the universe has also not been proven. On the contrary, researchers have noticed that the universe is not expanding uniformly everywhere. In order to explain these effects, dark matter and dark energy had to be used again. But here too we come to a crucial catch: neither the existence of dark matter nor that of dark energy has yet been proven. If we look at the facts, we have to say that this can no longer be excused. Our entire cosmological view of the world is based on a number of concocted theories, which in turn are based on observations, all of which can also be interpreted differently. Because all this never really made sense anyway, scientists invented dark matter, and now a telescope provides indisputable evidence that something is not quite right with all these theories. Yet science just carries on as before, trying to squeeze the new discoveries into previous standard models. In this way, our science may be missing out on an urgently needed new beginning. We need facts, not explanations. Most scientists cling doggedly to the Big Bang theory because it is supposedly still supported by a multitude of observations and theoretical models. But there are facts out there in these pictures, and scientists just don't want to admit it. They were wrong. Their previous models have been convenient and coherent answers to explain many aspects of the universe for almost 100 years. The theories were, and are, sold to us as truths. Hardly anyone doubted anymore that scientists really knew for sure about the Big Bang. But now everything is coming out. They didn't know, and most researchers are reluctant to admit it. But there is another way. There are new approaches, and we can hope that a new science of openness and truth will emerge. The Indian-Canadian physicist Rendra Gupta from the University of Ottawa in Canada has proposed a new theory. In his theory, Gupta combines the existing assumption of an expanding universe with the hypothesis of light fatigue and comes to the conclusion that the Big Bang may have taken place 26.7 billion years ago, which could make the universe twice as old as previously assumed. The idea of light fatigue, originally proposed by Swiss astronomer Fritz Zwicky, states that light simply loses its effect over long stretches of space, resulting in lower frequencies and longer wavelengths. If this is true, all of our calculations on the age of the universe and the age of early galaxies would be incorrect. The idea of an expanding universe would be completely different if the theory of tired light were taken into account. The theory of the variable constants of nature states that physical laws in the early universe could have been quite different from those of today. This would mean that fundamental physical constants, such as the fine structure constant or the gravitational constant, could have changed over time or assumed different values in different areas of the universe. Finally, the Mon theory tells us that the dynamics within galaxies can also be explained entirely without dark matter.